Hello everyone, my name is Omar. Welcome back to the channel. I hope you guys are doing absolutely fine. So this video will be a continuation of the previous video wherein we were discussing about BGP path attribute manipulation. So in the last video we have discussed about the first golden rule over here, the incoming updates affecting the outgoing traffic. If you haven't watched the video, you can watch the video. The link is in the description below. In today's video, we will continue our discussion on how outgoing updates affect your incoming traffic. So in today's video, we're going to talk about parameters about origin. We're going to talk about AS path, and we are going to talk about the med value. Okay, so now as the rule says, it's an outgoing update. So it will be sent from one router to another router, obviously. So R5 will be sending out updates by manipulating some parameters. So in our use case today, we are going to mainly concentrate upon R5, so R7 and R8 about these two networks, the 20.1.1.0 and 20.1.2.0/24. Now, if we see in the default scenario, I mean, we just have implemented BGP and we have advertised the loopback networks in BGP. So let's go and check what path R8 prefers to reach the 20 network. Let me get R8 on the screen. Okay, so here we have R8 and the command over here is show IP BGP. The BGP table for R8. The BGP table for R8 shows us that R8 is using 70.110.10.2, that is R5, to reach the 20 network. And so both the 20 networks are being preferred via R5. Now, if you look at the AS path, obviously it has a shorter AS path, hence the reason it is being preferred. Now, what you're going to do is we are going to send out an update from R5 towards R8 and we'll manipulate origin and the AS path. So we'll manipulate both the parameters in one single update. Now, when you talk about the algorithm which BGP uses to choose the best path, you have AS path as the first choice. Okay, the shorter AS path is preferred, and then you have the origin attribute. Okay, so you have the origin attribute after your AS path. Now in origin, you have two options over here. You have either I or you have a question mark. I is preferred more than a question mark, and right now whatever updates we see, they are coming in with this parameters. That is a known origin. This is an incomplete origin. So first what we will do is we will see that we will change this particular origin attribute from I to a question mark while sending out updates from R5 to R8. In that, even if we change this particular attribute, this won't really affect what R8 will choose even after the update is sent, because it will still see the shorter AS path coming in from R5. So we'll verify this rule first, and then what we will do is in the same rule we will increase the AS path which R5 is going to send to R8, and then how R8 is going to reach this particular network. So see, the rule outgoing updates is going to affect your incoming traffic. So when R5 is going to send an update to R8, R8 will either choose R5 or it will choose R7 to reach that particular network. So when I manipulate both these attributes, the AS path and the origin, I will see that R8 will start preferring R7 to reach the 20 network. So basically the path which I expect to see at the end of manipulating both my parameters will be something like this. Right, and if you see over here, when you're sending an outgoing update, my incoming traffic which was now coming from R8 is not going to come from R8 but is going to come via R7. So I have affected my incoming traffic on this particular interface serial 1/1. So this is my use case for today. So let's get started. Let's get R5 on the screen, and first let's manipulate the origin and check the result. So again, for the implementation, we will just note down these what AS path it is taking and what are the origin values, what are the attribute values over here, and then we'll go and change it. So this is what we have seen. Now let's go to R5 and start doing changes. Let's check the BGP table. So do show BGP. Yes, we are getting the 20 network. Do show BGP summary. Let's check the neighbor table just to keep just to get what is the address of R8 over here. So R8 is 70.110.10.1. Okay, so let's go and create a route map and change the parameters. So route map, let's name this route map as test today. Okay, so route map test, set origin incomplete. Okay, and apply a standard access list. So match IP address, let's say 44, and permit the rest of the networks as is. So route map test permit 20. Okay, once this is done, let's define your access list wherein we are going to permit the networks. So access list 44 permit, we are just going to do it for one of the networks, so 20.1.1.0. And okay, standard is access list 000.255. That's it. Let's go and send this neighbor to send this update to our neighbor R8. So router BGP 500 neighbor 70.110.10.1 route map test, and it's an outgoing update. Route map test out, exit clear IP BGP star out. Similarly, I will just go and clear the incoming updates on R8. So clear IP BGP star in. And now let's check the results. So we have the table without any manipulation, and now let's go and check the table with the manipulation. So you see over here, the origin has changed to incomplete. So we have a question mark in place of an I, but still the best path is via R5 because it is a shorter AS path. So as I was telling you, even if I change those values, that won't really affect any path, the path preferences for R8, because AS path is considered before the origin when BGP chooses the best path. Now in the same route map, I will go and change the AS path. So what is the AS path which we are getting right now is originating from 123 and going to 500 and then coming to R8. So if R8, if I just write down the values over here, so I have a question mark, then I have 123, then I have 500. And via R7, when it is getting the information, it's coming in originating from 123, going to 500, going to 670. So it is crossing 3 autonomous systems. You always read it from right to the left. So like this. Now what I will do is I'll prepend the AS path with some autonomous number value. So I'll just prepend it with this particular number 123. So what I will do is I'll just add two more like hops over here. So what I will do is I'll make it something like 500 123 123 123, and the origin will stay as question mark because we have already changed it. So this is the extra part which is I'm going to add in the existing AS path, the extra values in the existing AS path. Now when R8 will receive an update, so it will see that the path is a longer AS path, this 500 123 123 123 and question mark, and over here it is a shorter AS path. So this path will be preferred. So R8 will start sending out traffic from R7 to reach this 20.1.1.0 network, because I am just doing it for one of the networks. I am not doing it for the other network because I just want to show you the difference of, when we manipulate the attributes, what really happens in BGP. Okay, so that's it. Let's go and make those changes on R5 and then verify the result. So back to the terminal, route map test permit 10. Here I'll just type in set AS path prepend 123 space 123. That's it. That's the only change I want to make over here. And exit. I've already sent out this particular route map. I've changed the statement number 10. So just show you that. So show route map test. So you see in that particular statement in sequence number 10, I have now added one more value, the set clauses of AS path prepend. So this is the match condition. So this is the action which you have to do. This is the match condition, and this is the action which I have to apply to when this access list is matched. So I have increased the AS path length as well. And now again, clear IP BGP star out, the outgoing updates which is being sent to your neighbor R8. And now let minimize this, get R8 on screen. Okay, and here again clear IP BGP star in, and again check the updates. So here you see 20.1.1.0/24 is now preferred via R7, which is offering a shorter AS path as well as a known origin. Whereas the traffic coming in from R5, the updates coming in from R5, they are having a longer AS path and an unknown origin, because we have changed it in the same route map. And now the best path preference has also changed. So now R8 starts preferring R7. So what we have done is we have sent an update from R5 in the outbound direction to R8, and it affected the incoming traffic at R5 on interface serial 1/1. So this is what we wanted to verify in the first part of this video. So we are done with origin and AS path. Now in the next part of this particular video, what I have to do is I have to show you the med attribute, and for that I just need to load a different topology. There's some minor changes that I have done to this topology. So let's pause this video for a moment and get back with the new topology, and then we'll continue our discussion. Okay, so we are back with the small change in this particular topology. So what we have done, the small change which we have done is we have made R4 and R5 a part of a single autonomous system, that is AS500, and R6, R7, they still continue to be the same. R8 also continues to be in the same AS. So the only difference which we have done, the only difference in the previous topology and this topology is R4 and R5 are in the same autonomous system and they are connected via IBGP. Okay, so now we are going to talk about the med value. So med stands for multi-exit discriminator, or you can say is the metric value in BGP. By default, this value is 0. Now again, med is an outgoing update and it affects, so I'll just write it, it affects only the next AS and it is not propagated further ahead. So whenever I send out a value, so what I'm going to do is my use case over here would be that AS100 should be accessed only via R4. Okay, so we want only R4 to access autonomous system 100. So I'll be sending a med value out from R1 to R4, and I'll be sending a med value from R3 to R5. They belong to the same AS, and this is the only AS which will be affected. Apart from that, this AS670 won't get the metric value, so they will just consider, like, if something is coming in from AS500, that is what is going to happen. Similarly, AS800 also won't be affected with the med value. I mean, we won't see the attribute going after this particular autonomous system. So after AS500, it won't be really sent to AS670 and AS800. So this is about metric. By default, it is 0, and it is recommended to change on both the routers, like from R1 to R4 and R3 to R5. I mean, the default value is 0, but it's always recommended that you change it on both the paths which you have over there. So this is what I'm also going to do. I'm going to first show you how R4 is accessing AS100 and how R5 is also accessing AS100, and then we will change the metrics such that AS100 access is allowed only from R4. So R5 also will prefer R4 to access AS100. So let me get those routers over here. So on the screen, so I'll just take R4, show IP BGP. So it has access to AS100 for these two networks, the 20.1.1.0 and 20.1.2.0. Let's check R5. Okay, in R5 we have to check how it is going over there. So now see this particular network between R4 and R5, it is 172.16.20.0/24. So R4 is 4 and R5 is 0.5. So I see R5 is having two paths available, and it is preferring obviously the eBGP path, which is via R3, and it is not really preferring it via R4. So it's having in the database, in the BGP table you have this entry, but it is preferring it via R3 and not R4. So this behavior we are going to change by manipulating the med value. I mean, there are different ways to do it. You could have done it using local preferences also, but in this case we are just going to see med because that is our use case. You want to discuss how med also affects your AS path. sorry, your the yeah, how med affects your traffic. Okay, so let me go to R1 and do the configuration on R1, as well as going to do the configuration on R3. So continuing doing that, let's go to the terminal. Router BGP 123. uh okay, before that, let's set a route map. So route map med set metric, and in metrics case also, the lower the better. Okay, so set metric 100. Match only one network, so match an access list over here, match IP address 33, and allow rest of the traffic to go through as is. So route map med permit 20, exit router BGP. Okay, I'll just set the access list first. Access list 33, permit 20.1.1.0. Okay, and router BGP 123, the neighbor address. So what is the neighbor's IP address? 68.110.10.2, 68.110.10.2, route map med out. An outgoing update. Okay, exit, exit, clear, IP BGP star out. Similarly, I'll go on R3 and do the same configuration, but I'll just set the metric value to 200. Okay, so just repeat it. Just do that quickly. Route map med set metric, let's say 200, match an IP address, that's an access list 33. Again, I can use the same one, and I'll permit the rest of the traffic as is. Route map med permit 20, exit access list 33, permit 20.1.1.0 with a mask of 24, and send this update to R5. So router BGP 123, neighbor, and I suppose the neighbor over here is 69, I think. Just quickly check it. Do show IP BGP summary. 67, sorry. So neighbor 67.110.10.2, route map med in the outbound direction. Exit, exit, clear IP BGP star out, and I'll just change the I'll just clear the updates on R4 as well and R5 as well. Clear IP BGP star in, and on R5 clear IP BGP star in. Okay, so once that is done, I'll just make a note over here about metric lower the better. Lower the better. So obviously value, we have sent out a value of 100 from R1 to R4, and we have sent out a value of 200 from R3 to R5. Now let's check the difference on R5. That is where we expect to see the difference. So let's go and just check the table again. And yes, what do we see? We see the 20 network is being preferred via R4 because of a lower metric value, and it is not being preferred via R3 because of a higher metric value. So again, when we talk about the path selection algorithm in BGP, so in BGP we have seen, like eBGP is preferred over iBGP, but that rule comes in after the metric value. So it's, if I just recall the order, it's like the shortest AS path, then you have the better origin, then you have the lowest metric, and then it's preferred eBGP over iBGP. So we haven't really discussed, we haven't done anything about AS path and origin over here, but we have definitely done something about the med value, and that rule overrides the prefer eBGP over iBGP rule, and hence it is preferring the lower metric rather than preferring your eBGP over IBGP. So in the previous output, you could see that is preferring eBGP over IBGP because all the parameters were same. You had the same AS path length, you have the same origin, you had the same local preference weight and everything. And then it boils down to eBGP over IBGP. So now we have manipulated the metric value and we can see the difference. So this is what we wanted to discuss in today's video. So we have completed the path attribute manipulation in BGP. In the part 1, we discussed about weight and local preference. In part 2, we discussed about origin, AS path and metric value. I hope this has been informative. Thank you for watching, guys. Do subscribe to our channel, do like the video, share it with your friends and colleagues. And stay tuned for more such videos coming out every Monday and Friday. Take care. Bye-bye.